Hello again, welcome back. This is now 27, number 27, which should have been lesson 26, but I got diverted in the middle of it. But I had already recorded most of this lesson, so I'm going to piece together the bits that I have and maybe add a couple extra things, and hopefully everything will come out all right. So now we're really going to have a look at the command line itself, starting right now. Okay, so the first thing to do before looking at any code would be to look at an actual command line. That is, what's passed to a program. I still have that document. This here document tells me that for a COM program, the command line is passed in at position 80, halfway through the program segment prefix, which is 100 hex bytes. The first byte indicating the length of the command line, and then, in theory, 127 more bytes of command line data, always terminated by a line feed. I always get these confused, but that's the line feed. So that means at least there's one wasted character here, and there's one wasted character for this first byte that tells you how many characters there are. That's not really necessary because we know about this terminator. So we start with 128. We lose 2, so that's 126. And now the question is it possible to have a 1-byte command line? And well, I'm going to show you my code in a other box. Here's where I started out. Something like this, my program, okay? And disregarding all this stuff here for a minute. The bit that starts looking at the PSP assumes, and I've written it down here, 1 should be theoretically impossible. And this was the basis of my theory was this. If you're going to write the name of a program, like 2upper or something, and then you want to provide an argument, you would think you have to press the space bar and then type in the argument. That is, I can't just start typing the arguments here, because now that changes the program name. So that got me to thinking, well, let's just look, for instance, let's switch to capitals now. Still have that program. Let's look at, first, if I don't provide anything, I press enter. Now, going back to that document, at 80, it's my theory that it's going to tell me that there are no characters on the command line in this case. But this position should contain a D. So let's see if that's true. Dump 80. This is 0, this is D, so that is true. That's the 0 case. Alright. Now, according to my code, which I've lost now, actually I can have both of them. Alright, COM PSP. Alright. According to my code, even if you don't understand the actual commands here, you can get an idea of what's going on. I'm comparing what I've got from the PSP, that's this position with a number 2. Now this here is a little trick. I shouldn't really explain it to you because I'm going to get rid of this anyway. I can't jump from here to another address because it's too far away. And I didn't want to add a new label because it slows the compile down. So all this does is it jumps over this jump. But in fact, I'm gonna remove this code because what I determined last time I was trying to do this particular tutorial, by asking that question again, is it possible to have a 1 here? How can you get a 1 here? It's true that I can't, I can't type a, well, that doesn't matter. I can't type a letter here. But I could put something like a comma. And then it takes that. And look at this. I got a 1. So this command line contains exactly 1 character, and there's the terminator. So this assumption I've made, that it's theoretically impossible, is false. So I can get rid of this test, and there is no error exit 1 because that error exit 1 was the possible case something went wrong. And I don't think I need to subtract 1 from, well, I shouldn't. Clearly 1 is a valid possibility for the length of the command line. And the reason I was taking 1 away was for that same reason. Although it may not matter the way it's coded if this is a 1 or a 0. But I'm going to remove that too. And then if it's wrong, I can put it back. Okay. So there's that. So that's a possibility. Here are some other possibilities. This is where it starts getting a little bit hairy. You can certainly put in a bunch of spaces and type in a word. Hello there. And you could separate this from spaces. And then there's the possibility of quotes. And there could be trailing spaces and so on. Now, actually I got lucky there and there's no garbage on this line. So let's go back to the other box here. Get rid of this. And copy this command line over. Okay. Now, okay, here's the command line. There are 28 bytes, obviously not including the carriage return, from here to, oh, what's my command line? How are you to? No, it actually, this line is over more than 20, so it actually ends here. I'll get rid of that. Like that. Today. I think the D is that this dot represents this D. Okay. Alright. So the question is, in terms of, I still have that. No. What's that? There's another no. In terms of our C program, what do we expect to find in this pointer to strings? Okay. Is this an error? Is there an error here? Is something mismatched and so on? How should the spaces be handled? What essentially the question, my question is, I wish I could put something to indicate. Anyway, my question is, what would the user expect as the or the programmer as the argv list corresponding with this command line? Well, forgetting about the real argv of 0, let's let 0 be only, let's let ours only contain command stuff typed in, not the program name. All these spaces should be cut off, so the first argument should be the word hello. There should be no spaces in any of these things, unless of course there are quotes, then spaces could occur. Now I would expect the next one to be there. This is just what I would expect. I'm not saying this is the answer. But what's expected is almost more important than what the real, supposedly the real answer is. Because if you're returning something that's not expected, then your program is not behaving in a way that is useful for people. That means people have to guess about what the outcome is going to be. It should be natural. Now my question here is, and I put this one in on purpose, after the R here, so far we've just been removing spaces. What do we expect for the next argument? Quotations usually means a quoted string. And that means that any spaces between quoted quotes are not excluded. In fact, let me add another space here. What's today? Here. Let me add another 20. Just to emphasize. Okay. Now my question is, first, we see a quote. Now that normally, if this was like this, in that case, we know what the answer is, right? And move this here. If this is isolated, and even if this is touching this one, the answer in this case is no quotes, U space space 2 space. Okay, now I gotta indicate somehow that that's the end. In this case, that's what you should get, with no quotes. Alright. Now, if I bring this back one, then this would be like that. Okay, and the next would be the word day. And the last would be nothing. Because these are spaces and that's a terminator. Now, this case. Here's our case. Let me actually do it in real life. How many have I got here? Oh, I wanted to put another one here. Okay. See, the number went up. So, here's this case 2. Here's the end. Alright. So that's this case. Now my natural feeling about this, well, these are nothing, is that the quote, I should never get a quote, but this should not be regarded as delimiting to and day. This is not the same as putting a space here. So my natural guess, and then I went and tried it afterwards, is that what I should get for number 4 is U space space today and end, like that. And in fact, that's what you do get. So there's that case, and no 5. And this one doesn't have a 5th. This one has 5. That was this case. Yeah. So this is in fact upside down if you want. This gives you 4. This gives you 5. Because now there is a space delimiter between 2 and day, the quotes disappear. Because there's quotes between U and 2, extra spaces are included. So you always get 2 spaces. And if you try this with your regular C compiler, that's what you will get. So that's one of the behaviors of command line that you have to be able to handle. So now that's a little bit of a difficult parsing problem. You have to check and remember if the last one was space and what's the next one and so on and so forth. So I thought, first let me just try and handle the case where we have no quotes. Never any quotes. Now I know how to handle these cases. Okay? I won't get the same answer. In this case, this will disappear. Nothing will ever end with more than a space. You can have trailing spaces with the quotes. This bottom one, you, to, and they would break up into 3 things. And yeah, this breaks up into 5 things. Oh, is that 6? 6 things. 4, 5. Hello, how are you? 4, 5, 6. I should have one more on this one. I do have one more. 6. So this one's got 6 and this one's got 7. And if I'm able to work with this problem and get that done, then I'm one step closer to the answer. So my first attempt is, okay, ignore quotes completely, even if I put them back where they were. Where were they? Here and here. I'm going to include them in my answer. And I'm going to break on all spaces and clean up spaces. There's going to be a quote here. And this one, we have a quote here, and a quote here, and so on. Now this is a much simpler problem to deal with. We treat every character equally, except for the space. We truncate, we get rid of all spaces, and then return a list of strings, none of which contains any spaces. And that's the beginning point. Now I've probably used up all my time just explaining the beginning point. Let's see. Hang on. Okay, that's 30 minutes defining the problem. Next lesson then, solving the simplest case. Alright, see you then.